16. Example 8. I read the question. A body P of mass 10 kg is suspended by means of two light inaccessible strings, AP and BP, which are inclined at angles of 60 degrees and 30 degrees respectively to the downward vertical. Full stop. If T1 and T2 are the magnitudes of the tensions in AP and BP respectively, A. Write down two equations connecting all the forces on the body when P is at rest. B. Calculate the values of T1 and T2. C. Find the direction in which P begins to move when the string AP is cut. Take G equals 9.8. Solution. So we draw the first diagram. This is the particle. This is the particle P, or the body P. That is the body P. Body P. These are the strings. These are the strings holding it. The strings holding that particle. Now, the weight of this body P will be acting vertically downward. So we show the line of action. Show the line of action of the weight. That is weight W. Now, the downward vertical. This is the horizontal. This is the horizontal. This is the horizontal. Now we are told that these strings, the tensions are created here. Tension T1 and tension T2. So now the question says, like in a circuit string AP and BP, which are inclined at angles of 60 degrees and 30 degrees respectively to the downward vertical. If T1 and T2 are the magnitude of the tensions in AP and BP respectively, so T1, it means A is here, this is P here, this is P, that is body P, A is somewhere here. Now, you say this. So, this string is attached to this point here, point A. And this string is attached to point B here. So, T1 is the tension in AP. Yes, T1 is the tension in AP, while T2 is the tension in BP. Yes, in BP. Yes. Now we are told that these strings are inclined at angles of 60 degrees and 30 degrees respectively to the downward vertical. This angle, this is the downward vertical. This angle is 60 degrees. This one is 30 degrees, according to the question, yes. Downward vertical. So, now, yes, this is what we're given. So, if this one is 60 degree, then this will also be 60 degree alternate angle. Huh? Is it not? Huh?
That will be 30.
This will be 30. That is a complementary angles. This is 30 degree. This will be 60 degree. Because the reason is this. The reason is this. If I extend this to meet the horizontal line, it will be at an angle of 90 degrees. So this is the right angle triangle. And if this angle is 90 degrees, then the two remaining angles are complementary. If this is 60, this will be 30. The same thing here. The same thing here. It's another right angle triangle. If this one is 30 degree, 30 degree, this is at right angle. Then the two remaining angles are complementary. If this is 30, this will be 60. So that is how we have them. This is the first diagram. That is the first diagram. So now the question now is, so what is the question asking for? Write down two equations connecting all the forces in the body when P is at rest. This body P is at rest. It is at rest, meaning that the system of forces will be at equilibrium. So there are three forces here. What are the three forces in this system? T1, T2, and with W. So, how do we write the two, write down two equations. We can write down the two equations connecting all the three forces. Resolving the forces. Resolving the forces horizontally. Resolving the forces horizontally. I have, starting from T2, the horizontal component of T2 will be in the positive direction of x axis. So that will be T2 cos 60 degree, T2 cos 60 degree. Then this T1 is toward the negative, the component is along the negative direction of the x-axis. So that will be minus T1 cos 30 degrees. So there's no other force in the horizontal direction. That will be equals to 0 since the body is at rest. That is, it is at equilibrium. So it means T2 times, or T2 cos 60 degree is equals to T1 cos 30 degree. Take this one across. But cos 60 degree is half. So T2 times half is equals to, cos 30 is 3 over 2, I think.
Yes, 3 over 2.
T1 times 3 over 2. Therefore, now I can clear the fraction by multiplying 12 by 2. If I multiply 12 by 2, I have T2 is equals to
T1 root 3.
So 3 T1. Yeah?
Yes.
So that is equation 1. That is one of the two equations required. So T2 is equal to 3 T1. I can clear the question. To not affect the previous one. Resolving the forces. Vertically. Resolving the forces vertically. I have resolving this tension T2 vertically. So I'm going to have T2 sine 60 degrees upward. So it's positive. That is going to be T2 sine 60 degrees plus the vertical component of this T1 will also be in the positive direction, so it will be positive. Plus T1 sine 30. T1 sine 30 degrees is equals to 0. Oh, sorry. Is equals to W. Downward. Is equals to W. Yes. Like the downward force. But W is empty, so this means that T2 sine 60 is 3 over 2, I think.
Yes.
Plus T1 times sine 30 is half. W is mg. mg. Then again. So, M is what?
10 kg. 10 kg.
10 kg. And G is
9.8.
So I have okay, clear the fraction. I'm going to have so 3 T2 plus T1 is equals to 2 mg. Multiply 12 by 2, is it not?
Yes.
So I have so 3 T2 plus T1 is equals to 2 times 10 times 10.
9.8. 9.8.
Oh, is it 9.8 the same she used?
Yes.
Okay. Okay, this G is 9.8 times 9.8. We have to take G to be 9.8 meters per second square. So, then 9.8. 9.8 times 10 is 98 times 2. So I have T1 plus 3T2 is equals to
19.6 times. 196. Everything 196.
196.
Yes.
Equation 2. These are the two required equations. And they can be solved simultaneously.
That would mean B.
Yes? They can be solved simultaneously. From equation, oh yes, T is already made the subject of the formula. So, solving
That would B. That would be B.
B.
Yes, B. You are solving B now.
Okay, in order to solve B, oh?
Yes.
Yes. B part of the question. B part, we have to calculate the values of T1 and T2.
Yes.
So B part, solving equation 1 and 2 simultaneously. I have T1 plus some 3 T2. What is T2? T2 is some 3 T1 times some 3 T1 is equals to 196. You know?
Yes.
So I have T1 plus 3 T1 is equals to 196. You know?
Yes.
So 3 times 3 is 3.
Yes.
So it means 4T1 is equals to 196, or T1 is equals to 196 over 4.
That would be 49.
Okay, 49. Oh?
Yes.
Yes. That is 49 Newton. So that, I think I can clear the question now.
Yes.
Substituting for T1 in equation 1. Substitute for T1 in equation 1. So if I do that, I'm going to have T2 is equal to 3 times 49, because T1 is 49. So T2 3 times 49.
84.87.
84.87 Newton. That roughly equals to 84.9 meter.
Yes.
So then, how was the question? See, if the string AP is cut, I think it's AP that is cut. Huh?
Yes.
If the string AP is cut, then tension T1 is equal to 0. Tension T1 is equal to 0. So you can pause first. If the string AP is cut, then tension T1 is equal to 0. And hence, the body P will undergo a projectile motion in an anticlockwise yes, that way is anticlockwise. That
Yes.
This way is anticlockwise.
Yes.
In an anticlockwise direction. So that's all.